All right, hello again. So in this video, I'm going to demonstrate how to write and run Python code in a script file. This will let you write Python code outside of a Jupyter notebook, which allows you to then create programs and applications that can more effectively automate your computer rather than necessarily just doing sort of a simple data analysis. In effect, we're going to be creating small command line applications. This is similar to what we did with our shell scripts back in the first module, but we're going to be writing them in Python, so we actually get a lot more expressive language, and they're much more easier to understand, and we can actually do a lot more with them. So as always, I recommend that you work along with me to try this stuff out and sort of get a sense for how it goes. The best way to learn is to learn by doing. So let's get started. All right, so in order to start, you're going to be writing your script inside of a file. So we need to have a program to use to actually write these files. We don't want to just like type them, where to actually type them out. So I recommend creating and editing these files with an editor like Visual Studio Code, which is what I have open here in the middle of the screen. So I'm going to go ahead and create a new script file. So I'll go to File, New File in order to do that. I'm then going to save this. So I'll do File, Save As. Wait for it. Computer's running a little bit slow. So I'm going to save this file as a file called script.py. So the important part here is the .py extension. The py stands for Python, and that's going to let us. It's going to tell a bunch of different programs that this is a Python script as opposed to anything else. The actual name of the file doesn't matter. I'm calling it script because it's a script. You could call it the name of your application. You can call it really whatever you want. The other important thing to do is to note where you're saving this file. So I'm going to save this onto the desktop because I want to make sure that I know where the file is so that I can go ahead and execute it later. So I will save that onto the desktop. Visual Studio will prompt you to, if you want to install a Python extension to help you write more stuff doing Visual Studio. I'm going to ignore that for now. It's not necessary. It can be useful, but it's not totally required. And then if I drag this over, we can now see that there's now this .py file sitting on my desktop for me to play with. So inside this file then, we can write any kind of Python code that we want. So we could do this is our first program, so let's go ahead and we can print out hello world. And we're gonna use 2 exclamation points because it's exciting doing the shell script stuff. And basically, anything that you would put inside of a cell in Jupyter, you can put inside this notebook, and it works exactly the same way. All the formatting, all the syntax is exactly the same. So we're going to create that file. I'm going to make sure to save this file, because you see currently it has a circle at the top, which means the file is unsaved. So I'm going to File, Save it, in order to make sure that it gets saved. And there we have a script, and now we're ready to actually. So we have a program that does something very simple. It prints out hello world. Okay, in order to actually then execute this program, we're going to need to then open up the command line. So we end up going to have sort of 2 things going on here. We've got the script itself, and then we've got our command line window. So in order to make sure that you can run this from the command line, you're going to make sure that you have Python installed and available on your command line for you to be able to work with. So you can check that by using the command python --version. And as long as you see something that looks like Python 3.7 or 3.73, 4, whatever version you happen to be on, you're fine. Everything's ready to go. You can do this kind of work just fine. If you don't have that working, then you want to go refer back to some of the installation instructions or check in with me, and we can be able to help you make sure you get your system installed. All right, so once we know that we have Python working, we're going to need to do 2 things. We're going to need to navigate to the folder that has that script, because I want to make sure that I'm in the folder with the script in order to be able to use it most easily, more effectively. So because it's on the desktop, I'm going to do cd desktop in order to change folders into my desktop. And then now that I'm there, I can actually execute the script by using the command Python. So I'm going to type Python because that's the program I want to run, but then I'm going to pass it an argument indicating which script, what program I want to run with it. So I'm going to say that I want to run this thing called script.py. That's the name of the program I want to run. And when I go ahead and hit enter and run that, you'll see that it executed my code. It printed out to the command line the text hello world with our 2 exclamation points. All right, so running a command line script on Windows works pretty much exactly the same way, assuming you have everything sort of set up correctly. So I'm going to show you on my Windows machine here. So again, assuming you've got everything installed, working correctly, you should be able to run, in something like using the WSL, you should be able to run python --version to indicate that, again, I have Python installed, everything's up and running and ready to go. Because my script file is again on my desktop, I'm going to cd into my desktop to where that file might be, and then I can use the exact same command, Python, and then the name of the script file, which in this case is again script.py, in order to execute my program and be able to see that running and again get my hello world. If you're using git bash, here, let me is this? If you're using git bash, it's again going to work exactly the same way. I'm going to run Python. I'm going to check to make sure Python works in git bash. It does. It's the same thing. I can then cd into the desktop. I can then run Python script.py. And again, I'm getting the same kinds of results. With git bash, you might have to use the winputty command before you type the words Python script. I don't think you'll have to do that. Clearly, it worked fine without that for me, but depending on your setup, you may or may not need to do that in order to make things support interactive. WinPutty is the thing that lets Windows talk to git bash in a more effective and decent way. All works out the same way. The other option you'll have on Windows to run Python scripts if you're having some issues with this stuff installed is that because you've installed Python via Anaconda, you're also provided with what's called what's called the Anaconda prompt, which is basically a way of opening up a command shell that has sort of all the Anaconda stuff loaded and available. So all Python will definitely be here and should definitely be working. So if we get run Python version here, it's still working installed the same way. I don't think that's just because I've installed it correctly on my machine, but that should get working no matter what. And then we can do the exact same stuff. We can go cd to our desktop, and we can run Python script.hello world. And I've now said hello to you like 4 times, so hopefully this all makes sense. Again, this should work fine as long as you've got Anaconda installed, and if you've got things set up correctly, then you'll be able to run scripts no problem. If you have some issues with this, please check it individually. Individual machine, everyone's machine is slightly different, and there's always some weirdness that happens whenever you're trying to run something, particularly on Windows. All right, so we've written our basic shell script. We've managed to run it and get this thing executed. But the thing to note then, of course, is these shell scripts can actually contain lots of code. It's not just one line. We can put lots and lots of stuff in there. You can basically think of it as like a really big single Jupyter cell, and so anything you would put in there, we can put in our script as well. So I can print out hello world. I can print out another message like it's a very fine morning with another exclamation, that's 2 exclamation points. And then I can run this again. Python script.p. Right, when I run the program again, the interpreter is going to go to my script and it's going to run each line top to bottom, performing that action. Just like when we execute a Jupyter cell that has lots of code inside of it. So I can have multiple print statements. I can define functions. So I can define our classic greet function, right, which is our greet takes in a name and will then print out hello, plus the name. Right, this is again this is our standard greeting function that we've used previously. I can then call my greeting function, right? I could say greet Joel, that's me, or greet, how about the morning? Let's greet the morning, that sounds fun. So I can then be able to call my greeting function, which will again do the exact same thing we'd expect to do in Jupyter. So if I then go back up and rerun my code, I'm using the up arrow in order to sort of instantly go back to the previous command. That's a shortcut to avoid having to type it out over and over again. But when we execute that file, then I get hello world, it's a very fine morning, and then there's my hello morning, which was what my greeting the morning process was doing. Cool. The thing to note, though, about this is that because it's running that code top to bottom, it means that you would need to do things like define functions before you use them. If I try, and this is the same thing happens in Jupyter anyway, but if I try to say, for example, call greet up here with my printing before I've actually defined the greet function, when I execute this, I'm going to go ahead and I get an error, right? It prints out hello world, it prints out it's a very fine morning, but then it gets to line 3 where it tries to greet the morning, and then in line 3 it hits an error, right? The name error says that greet isn't defined, it doesn't know what greet is because we haven't actually explained what greet is until line 5 further down. So unlike in Jupyter where sometimes you can run a cell over and over again, that sort of like lets you get around the ordering of things, in a script they're always run from scratch. It's almost like you've always restarted the kernel, you're always running that one cell on its own, so it's going to reset all the way through as you go. This also shows up what an error message looks like on the command line. So it's going to be the same structure and the same thing that we got in Jupyter, right? There's our traceback, and we've got our line number where the line is. We've got our particular error type as long as the message. And you would use the exact same debugging strategies and debugging tips you would use on Jupyter in order to debug stuff on the command line. It's a little bit more difficult sometimes because your script ends up being so much longer, right? You basically have a single cell in order to do all that work, but it's the same general kind of process. If you're trying to isolate an issue, figure out exactly what the issue part is, you can do things like comment out large chunks of the code so that you haven't deleted them, but that way they're not being run, they're not being interpreted, and that will help you be able to sort of isolate down and track down the problem you're trying to solve. So I noted this earlier, but I want to make sure to highlight it again because it matters a lot when you're dealing with command line. So in particular, it's really important to distinguish between when you are returning from a function and when you are printing from a function. So in Jupyter, what we've done previously, right, we could define our greet function that can return a string, right? We're not printing it out, we're just returning that value to be used later. And then if we call that function, what Jupyter will do is it will output the result of this last line of code, this last expression, so it'll show us the result, hello world, even though we didn't print it, because we just returned it, and because of the last thing we did, it gets shown in Jupyter anyway. If we then swap back though to our command line, so in our script, if we have the exact same code, right, it's doing the exact same thing, if I execute this script, then you'll notice that nothing happens, right? It didn't print anything. On the command line, the only things that will actually show up as text on that screen are going to be things that you actually printed with the print command. So just returning a value, just having it be the last line of your cell, the last line of your script, won't actually do anything. So you really want to distinguish between, am I printing something that's going to show up in that command line, it's going to be outputted to the user, or am I returning something that's going to be used internally by the computer and by the code, the program in order to do that kind of work. So if I want to see the results of this function, or I want to see the hello Joel part, what I want to make sure to do is I want to take this result and I'm going to save it as a variable. So for example, maybe this is going to be my greeting, right? I could save that as a variable and then I could print out that variable. Once I've explicitly said print the thing that that function returns, now I get my hello Joel and my message is good and life is fine. You don't, of course, if you want to, you could skip the intermediate variable, but I recommend having lots of intermediate variables to help clarify what's going on, where things are happening. Okay, so print is let us to give output to the user. If I want to show something on the command line, I have to use the print function. But what happens if I want to get input from the user, right? What if I want the user to be able to, using my command line application, be able to actually like give me some data, to be able to provide some information for me to use? Well, the way that we can get information from the user on a command line script using Python is by using a function called input. So input is a function, just like print is a function. It's going to work kind of like the opposite of print. The input function is a built-in function that's going to prompt the user to enter in some text, and then it's going to save that text and make it available to your program. So the way we call it is by writing out the text, the function input, right, with the parentheses because it's a function. And then the argument we're going to pass into it is going to be what's the prompt that we want to give the user. So I might say that I could have an input that would be a prompt of what is your name, and that will be my line of code. So that when I then execute this code, what the interpreter will do is it will read that statement, and then it'll pause. Basically, the program will stop and wait for the user to type something in before it then moves on to the next line of code. So to demonstrate sort of what this looks like is on my command line, if I run Python script.py again, you'll notice it prints out what is your name, question mark, cursor. I can then type in my name, Joel. And once I do that, it continues on to the rest of the program and then ends because it's not doing anything else. You'll notice that the cursor that I had right here was right next to the space, so it ends up looking a little bit messy and kind of, it just doesn't look real nice. The way to fix that is actually to make sure that the prompt has an extra space at the end. So that way what I'm going to prompt out is going to be what is your name space, so that when the user starts typing, they're going to start typing after the prompt, which means it'll be start being after the space. So having that sort of trailing space at the end is often sort of a clean way of making your code work. So I can then print out hello at the end just to sort of demonstrate what happens here. Not Jello, hello. So that when I execute my script, it's going to prompt me for my name, and notice the space, right? Looks good. I can write my name as Joel. And then once it does that, once that line has finished, once the user has typed something in and hit enter, it'll then, the interpreter goes on to the next line so it can print out hello, and my program can end. Good. All right. So the input function then, this function, right, the argument it takes is going to be what prompt we want to give to the user. What that function is going to return is going to be whatever string the user typed in. So if we ask the user for what is their name, we need, in order to save that value and use it later, I have to be able to take the result of that input function and save it as a variable in order to use later. So for example, I can make a response variable whose value will be whatever is returned by this input function. So that value after the user types in, when they hit enter, that value is going to get returned by input and then stored inside response. And now that I have that, I mean, here we can give it a slightly better name, right? We can call it name. So now it's being saved inside this name variable. I can print out hello plus the name, right? In order to do concatenation. so that I can now ask the user what their name is, and then once I have that name, I can then say hello to them in particular. So I can now run my program, and it says, what's my name? And I say Joel, and it says, hello, Joel. It greeted me by name. Look, we can do more, right? We could say, what is your name? I am the morning. Hello, morning. What is your name? I am a class. Hello, class. Like, we can do the same kind of program. We now have some variable input in order to how everything is going to work. So we can do this work where we can then say concatenate to some text. We can go ahead and if we go put our greet function back in here, name, print, hello, name. That's the same I just had. Then we can go ahead and we can even just call our greet function. So we can be able to sort of get these things all tied together, and we can basically, again, and this is mostly just doing the same thing, sort of restructuring the code for my next example. What's my name? My name is Joel. Hello, Joel. We're good to go. So one important point that tends to throw off a lot of people, and it sort of gets, they struggle with this a lot, is that the input function always returns a string. It's always going to produce text. Even if the user types in a numeral, even if they type in a number, even if the question that your prompt asks them for numbers, the thing that input returns is always going to be a string. So as an example, with a slightly different script, so maybe I'm going to have an input where I'm going to tell the user to give me a number with my space. I'll save that result in a value called number, and then I'm going to try to say add 3 to that number, and if it's a number, I should be able to add 3 to it, and that should work perfectly fine. And then I can say print out the result afterwards. So if I execute this let's clear it out. If I execute this program, it's going to say give me a number, and I can type in my favorite number. How about is 6, right? So there's a number. When I hit enter, you'll notice that I get an error, right? There's that type error thing again. And the error here is I'm only allowed to concatenate a string to a string. I can't take a string, right, the numeral 6 in quotes, and add 3 to it. So this is the equivalent of me trying to take 6, a string, and add a number to that. But I can't do that because I want num to actually be a number, but it's not. Input, it will give me a string all the time. There's no way around that. It always gives you a string. So what we then want to do is that because it gives me a string, but I want that to be a number, it means that we have to explicitly convert it into a number for us to be able to use later. So rather than just being able to say add num is equal to 3, we're going to want to make a num as number variable, for example, and we can do that by using a function like the int function, this is one of our type conversion functions, to say let's take this number, right? This was number as string. Right, I'll rename it so we can see what's going on. Right, we're going to take our number as string, and then we're going to save it as a number as number, and then our bigger number can be the number as number plus 3. Right, so the idea is we're going to take this thing that I got as a string, but because I know it's a number, or because I asked the user, please give me a number, I'm going to convert it into a number, and then I'll be able to add 3 to it, and then be able to print out that result. So if we save this, you got to make sure you save your program every time you modify it. So you save, go back to the command line, run our script again, give me a number, my number is 6, and a bigger number than 6 is 9, and apparently there's an extra space there because I threw an extra space. There we go. Cool. Hopefully that makes sense. So I'm going to note here that I'm only using this int function because I want to convert this thing into a string. Into a number, sorry, it's already a string and I want to make it into a number. If I ask them for their name and it's already a name, I don't want to convert it into an int. I don't need to convert it into a string because the thing they give me will already be a string. So if I ask for their name, I don't need to then convert that name into a string. It's already a string, right? That's what we're giving already. So the only time we're going to need to do this would be to eventually convert into a number. The common way you might see to do this is you might skip this intermediate variable step of having a num string and just say, let's take that resulting input and let's just turn it into a number. So we're going to get this resulting value. We're going to take that value, pass it immediately into the int function in order to take that resulting number and then be able to save it and automatically get it as a number. So we can sort of skip that middle step, and this will help sort of tightens up the code a little bit and makes it potentially a little bit easier to read, but also sometimes harder to debug. So either approach is fine, but you'll often see this kind of thing. So if you see the int input, that's what's going on there. And again, this works the same way, 6, 9. I'll also note then that like sometimes what will happen is that you're going to ask the user for a number, they give it to you as a string, because that's what input does. You convert it into a number, you do some work on it, and then if you decide you want to say like concatenate that back together, right, combine it with something else, like maybe I want to then say, right, I don't know, can I have some amount of dollars where it's that bigger number? Then that means that if I try to just do this general kind of string concatenation that we've done before, I give in my 6, I'm going to get that same string concatenation error, which means I now need to take this number, but because I'm in the separate step, I want to take that number and combine it with my dollar sign, I'm going to go ahead and use my string function to convert that number back into a string. So the way to think about this is there's sort of two, I can't cover the screen for you to see, but there's sort of two separate steps here. There's one which is I need to get a number from the user, which means they're going to type in an input, which comes as a string, so I have to make that into a number. Once I have that number, I can do things with it, but then in order to give it back to the user, I have to convert it back into a string so that I take my string, turn it into a number, do work with it, and then convert it back into a string in order to output again later. So it looks like we're sort of jumping back and forth between types, and we are, but a lot of this is about keeping track of what task am I currently doing with that variable. Am I trying to say, get the thing from the user and I want it to be a number, or am I trying to give back to the user in order that it means to make it back into a string? So it's okay if shifting between what types we're doing. That's sort of a normal way of trying to write these kinds of programs. Okay, so there's one more thing that I want to demonstrate in terms of Python scripts. This is a moderately advanced idea, and it can actually be fairly confusing, which is why I'm going to try to go through it in a video so you can see how this works, because it's really hard to explain outside of that. It's good for you to know because you may encounter it with other code or examples that you look around with and find online. It's used almost everywhere. It's not going to necessarily be super necessary for this class, but it's a concept that I kind of want you to be familiar with. So this is sort of my fair warning that this might take a bit of thought. The previous 20 minutes of the video are more in line of what you really need to be comfortable with for command line stuff, but this is sort of this extra piece to be able to worry about. Okay, so let's get into it. So one of the advantages of writing code inside of a script is that we're able to actually reuse and import that code into other sources, like to say into a Jupyter notebook. So for example, I have my script here, which has got all the code that we've written so far. And I have this amazingly complex greeting function, right? This took hours to write and I got it working, right? Pretend that this is really important and I have this function. I want to be able to reuse that later. So maybe that inside of a Jupyter notebook here, I want to be able to use that greeting function. I want to be able to call greet morning. Like I want to be able to do that work, but I don't want to have to define the greet function because I already defined it elsewhere inside this other script. Well, it's possible to actually import that script the same way that we imported math, the same way we imported random. So the same way that we said, hey, math module, get the math box out, get me all the functions from that box. We can do the same thing with our script. I can say, hey, get that script box and get all the functions and stuff that are defined inside of that script. So in order to do this, you're going to need to make sure that your script and your Jupyter notebook are in the same folder. It's possible to do it if they're not in the same folder, but in general, the easiest way to do it is make sure that the Jupyter notebook, right, the IMT511 file and your script file are inside the same folder, so their paths are right next to each other. They're in the same place. We can then go inside of Jupyter and we can go ahead and use the import command just like we've imported from math or random, but instead of importing math or random, we're going to import the name of our script file. So in my case, that file is called script. I'm not putting the .py here. I don't need to indicate the actual file name. I just need to put sort of the name of the file without the extension. So if you named your script was named app, you would import app. If it was named hello, you would import hello. Our script is named script.py, so we're going to import script. So once we do that, we can actually go ahead and run this code, and that will import our script. It'll make it available inside this Jupyter notebook. So I'm going to go ahead and do that. So notice what happened is that I imported my script, and then what the Python interpreter does is it's going to go to that script file, and it's going to immediately start executing each line of code top to bottom. So it's going to go to Visual Studio here, and it's going to do the first thing, which will be define the greet function, which is what we wanted. But then it's going to say, input what is your name, and ask for the name. And look, there's my input box as it shows up in Jupyter. So I would say, for example, okay, my name is Joel, and then it printed out the hello Joel, which was my next line, right, printing out the greeting. Then it has my give me a number thing, right, and say, oh, there's my number 6, 56, why not? And then it asks for the $59. And then once that finishes, I then have all this stuff that's happening. Great. Okay, so we'll come back to that in a second. Cool, so I've now imported the script. I have these things available, which means that because I've imported the script, I can use functions like greet and even variables like name or num as number and I can use those later down in other cells. So for example, I can say, because the script box, I got the script box, so I'm interested in the greet function from the script box. So I can talk about script dot greet, right? Remember the dot's like the apostrophe s, so this is the script box's greet function, and I can say, please greet the morning. Execute. And then there's my hello morning, right? I'm executing that function that I've written somewhere else. I don't have to rewrite it. I don't have to paste it into another script again. I can just import it in order to make it all work. So that's vaguely useful, and it's sort of a way that Python scripts often get used, and this is effectively how modules are built, right? The math module and the random module are literally just .py files that have a bunch of code written in them that you can then import to use later. Okay, the problem then, of course, was, though, that when I imported that script, I had to do all this stuff, right? Is I really wanted to just import the script. I didn't want to have to answer a whole bunch of questions at the same time, right? I just want to be able to use your greeting function. I don't also want to have to like go through this interrogation to be able to explain how I want to do that stuff. So if we look at our code, what this really means is that I want to define the greeting. I want that code to be run, but all this other stuff, this thing that's not actually creating variables that I want to be able to use, I want to be able to only actually run that code, use that code if I'm running my script from the command line, not when I'm importing it into Jupyter. Like when I'm on the command line, right, when I run my script from here, I want to be able to specify that I'm Joel and that my favorite number is 6. But when I'm in Jupyter, I don't, when I import this module, this function, this script, I don't want to have to do all the other stuff. So what we need is a way to be able to say that this block of code here, all this stuff, I only want to execute if I'm running from the command line. So that if we're not running from the command line, right, in that else case, that we don't actually do any of this work. So I want to basically be able to say that if I'm running from the command line, run all this code. Well, we can actually do that. So in Python, if I want to say if there's some situation, then run a block of code, I can do that. I would just use an if statement, right, and then I would just I would just indent this stuff, so it'd be part of this block. So the question is then, what's the condition? How can I determine if I'm inside on the command line? And Python actually gives us some code that lets us be able to do that. So it's going to look a little bit weird. I'm going to type it out and we'll go through it. So we're going to ask, say, if underscore underscore, there's 2 underscores here, right? Not 1, just 2. Name underscore underscore equal to underscore underscore main underscore underscore. So important note, because this is a really common thing people mess up, there are 2 underscores on each side of name and on each side of main. It's not 1, it has to be 2, and that's really important. You have to get that correctly. These things are these are previously defined names. They have to be called this. Similar to the way that print has to be written as print, you can't say PRT. You have to actually write out the whole word. You have to write these things out in the exact same way because that's what's built into the Python language. That's how it knows to understand things. All right, so what does this mean? So this name variable is a script that is a variable that Python provides that gets built in, sort of similar to the way the print function is built in, that is going to have a value that represents which module is currently being run. So if I basically say, like, if I want to actually print this thing out, I mean, it's a variable, I can print it out. Yeah, I'm gonna comment this out for a second so we don't have to worry about it. So I can just say, let's print this thing out to see what module is being run. If I'm on the command line and I execute my code, then you'll see it prints out the underscore underscore main underscore underscore because that's where this script is currently the main module, right? That's the primary thing. That's what's running from sort of the top level module. That's the main piece of work that's happening. On the other hand, if I go back to my Jupyter notebook and I re-import my script at the top here, you'll notice why didn't it do anything? The reason doing anything is because I hadn't reset the kernel, so I'd already imported the script, so it wasn't importing again. So I did kernel, restart, clear output in order to reset, and we're ready to go. Back to where we were. So I'm going to, if I go back to my Jupyter notebook here and I go to import script, then you'll notice that the name of the script module is actually going to be the script module. It's not the main thing. It's not that thing at the top. It's not the starting module. It's not the script that's being run from the beginning. Jupyter is the main module, right? Jupyter is the thing that really matters. The script module is just this other script thing, right? So if I'm inside Jupyter and I say, hey, Jupyter, what's your name? Jupyter's name is main, but my script file is not, right? So effectively the main name is assigned to whoever is like actually running the code. So in short, what this means then is that if I check to see if this script is running when his name is main, then that means is this script the person who's being run at the top, or is this script been imported elsewhere? So if name is equal to main is the sort of the way of writing, is this being run from the command line? Is in short what's going on here. If it's being imported, then this name would be something else, and therefore it won't be considered. So what that means that we can do is I can put in all this code again, right? All my interrogation work here. I can then execute my script, which tells me that I'm running main, and then it asks me my name is Joel, and my favorite number is 6, and like that all works as expected. I'm gonna get rid of this print statement to clear that out. But then what that means is that if I go back to Jupyter and I reset my kernel again, I can just delete this guy. Then what it means that when I import my script, it imports just like the math imports. It doesn't also ask me a whole bunch of questions because it only actually it executes this defining the function work, but then it gets down to here and it says, hey, script file, are you the main? And the script file says, no, Jupyter's main. I'm just like the secondary dude. I'm just like this other guy who like hangs out in the back. Don't bother me. So it doesn't actually end up running any of this block doesn't execute, right? This if statement becomes false. It doesn't end up executing in this extra work, so that we've written some stuff that happens only on the command line, but not in Jupyter if we want to import this later. But nevertheless, because my function definition was defined outside of that if, it was defined at sort of without being indented anywhere, it was defined in a way that it's going to happen no matter what. It means that I can still use my script's greet function and I can still greet the morning happily and everything works out well. So in short, right, the summaries of this is that if you want to check to see if something is being run from the command line is what's called a top-level module or a top-level script is the way that it gets worded sort of formally, is you're going to use this magic line of Python code. Yeah. Cool. You know what, let's leave this here. So we're not going to be importing modules in this class. We're not writing modules to be imported into other modules. That's good for if you're building much larger scale applications than we would clearly cover in an intro class and that you'd probably even actually do in a lot of data science stuff, though it might show up. So it's good to know because you might do it later, and it's good to know because if you start looking at examples or if you start looking at help for how to do Python stuff, you're very likely to come across somebody who's done this because it's a very standard. It's what you do effectively in every single script you write. You're going to include this if name is equal to main. And I don't want you to come across that and be like, what is going on here? I want you to sort of understand that, at least have a basic idea of what that line of code might mean, even if you're not necessarily going to be able to choose when or how you want to use it. So it's not super important for this class, but it's really, really good information to know, so I want to take some time to go over it. Cool, and that actually about covers the command line scripts. So again, overall, the main thing to take away is these are pretty much one giant Jupyter cell that you're able to execute from the command line, and we can use them to define a bunch of functions. Our general process would be define a bunch of functions at the top, right? We would define greet, we could define, I don't know, other stuff, which I can't think about because it's the morning. But we can define a bunch of functions at the top, and then once we've after we've defined all our functions, inside this main block, right, this thing to make sure we're actually a script, that's when we would go ahead and actually call those functions to have them do some work. Good.